Cool. Thank you very much. Like you said, I'm Guillermo Fisher. I've been in tech for around 20 years. I'm currently a fractional CTO and CISO, which is a fancy way of saying I'm a contractor that works on, a consultant that works on a retainer. I have led engineering teams and security teams over the course of my career. I've helped people build out high availability workloads, infrastructures that support production workloads in AWS, GCP, a little bit in Azure. I'm also an AWS data hero, so I talk about data and analytics services in AWS. I'm not here in that capacity today, just a regular technology professional today. And I also run a nonprofit called 757 Color Coded. And that nonprofit, 757 is the area code for where in Virginia I live, Hampton Roads. And we help people of color who want to break into tech, and we offer free training to them. And folks that are in tech, we create a space for them to talk and share knowledge. And we welcome all people. We just kind of target the programming towards people of color. So that's me. And today we're going to talk about, that's my face. We're going to talk about incident response in the cloud. I've been working in the cloud for quite some time. Great opportunity for innovation and moving really quickly. There are definitely some very unique threats to the cloud, very unique challenges in deploying things to the cloud. And so I want to talk about specifically how you can strengthen your incident response plans to make sure that you're prepared, right? So basically the difference between managing an incident and a catastrophic issue is how you respond when an incident happens. And so we're going to talk through all of that today. The shared responsibility model in the cloud helps you understand where your responsibilities lie and where the CSP's responsibilities lie, right? So this is what it is for AWS. It's pretty common. It's pretty much the same for the other ones. But at the bottom, you'll see what AWS is responsible for. So that is their data centers, their servers, their networking. They are responsible for the security of the cloud. So everything at the hypervisor layer as well. You or us as customers are responsible for our applications, our data. We are responsible for what we deploy into the cloud. We're responsible for securing that, making sure our configurations are correct and secure. So AWS, responsible for security of the cloud. You as a customer are responsible for security in the cloud. GCP is pretty much the same. They call it the shared fate model, but it's the same thing. Google is responsible for the security of the cloud. Everyone, and you as a customer for security in the cloud. Can you all hear me fine, by the way? All right, cool. Same for Azure, Microsoft, of, you, in. Let's get into the threats. So, like I said, pretty unique threats in the cloud. Some of them you might experience in on-prem things, but with the cloud in particular, misconfiguration is a pretty common issue that you run into. So you might have a storage bucket that is publicly available. You might have a security group that is way too permissive, right? You might have port 22 opened up to the whole world, right? Which is something you shouldn't do. These kinds of things happen all the time, and they are pretty common issues that companies face, right? So it is your responsibility to make sure that you're configuring things in a secure way. Now, your CSP is not going to catch those things. They might make recommendations as you are building out your infrastructure, but it's your responsibility to make sure that you either follow those recommendations or do whatever you need to do to make sure that your deployment is secure. Identity and access management weakness, right? IAM stuff. So you might have roles and permissions, roles and users that you've created, for instance, in AWS. And so you have to protect yourself from account hijacking and things like that. And so you want to make sure that in addition to having roles and users that have the right amount of permissions, you have things like multi-factor authentication enabled so that you can prevent people from manipulating or exfiltrating data out of your systems. APIs are the backbone of cloud applications, and so it's your job to make sure that your APIs have authentication and authorization, and you're using some kind of encryption to encrypt data that's being sent over your APIs. And then most infamously, data breaches, right? So In the cloud, data is stored across geographic regions. It's accessed remotely. You want to make sure that you have policies in place to protect the data that you are storing in the cloud. A pretty recent example of misconfigurations, AL-Beast. Anybody here familiar with AL-Beast? No, okay. Well, earlier this year, around August, some researchers found that ALB, which is AWS's application load balancer tool, was misconfigured for about 15,000 of the applications that were using it. So in total at the time, there were around 371,000 applications that were using ALB, but the 15,000 here were vulnerable to this issue where JWTs or JSON Web Tokens could bypass authentication if they weren't validated properly. So just another example of the shared responsibility model coming into play here, right? So while AWS's ALB is itself a secure tool, it is our responsibility to make sure that we configure it in the right way so that we are protecting our applications, protecting our data from prying eyes. Having a strong incident response plan is critical when you're in the cloud. And NIST provides a four-step framework that can help guide you in creating an incident response plan. It's NIST 861 revision 2. And so the 4 steps, preparation is the first step. So that is you developing an incident response plan, identifying the incident response team. And so in general, there might be an incident commander who is responsible for managing communication and making decisions during an incident. There might be what's called a scribe who actually takes notes during the incident to make sure that all of the actions are documented. And then there are on-call engineers, et cetera, subject matter experts that are involved. So you want to make sure you know who that team is. You might have legal and HR and an executive member of the executive team as part of the team as well. Make sure those people have tools that they need, have access to those tools so that when an incident happens, they are able to respond to it. And you want to practice the plan. That's also part of the preparation. Detection and analysis. So you want to have some tools to monitor your systems, to alert when there is something going on, and you want to make sure that your team can actually analyze logs, look through things, do some forensic investigation to determine what's going on. Containment, eradication, and recovery. So you want to contain the incident, limit the blast radius of the incident. You want to resolve it completely, and then you want to restore your services back to full health. And then after the incident is your post-incident activity. So that's usually a post-mortem, in addition to some other activities, but the post-mortems are a really important tool in helping you continuously improve and continuously strengthen your incident response plan. So we'll talk a little bit about those in particular, because I think they're a part of this process that sometimes it's overlooked. With respect to postmortems, you want to make sure that they occur in a timely manner, right? So at places that I've been, we've said you have to have a postmortem within 1 week of the incident happening, because you want to make sure that the folks that were involved still have the events fresh in their minds. You will have documentation as part of the stuff that got documented when the incident happened, but there might be some things that didn't get tracked in documentation, so you want to make sure those things are still in people's memories. You may have heard of a blameless postmortem, so you want to make sure that you're approaching it objectively. You're there to find facts, to uncover facts, not to point blame during the postmortem. You want to do a root cause analysis, obviously, to understand the underlying reason why the incident happened, and make sure you know what needs to happen to prevent it from happening again. And then, most importantly, you want to have some actionable takeaways. If you are leaving a postmortem and you don't have actions afterwards, then you're not being as effective as you could be. So in addition to having actionable takeaways, it's important to make sure that the tasks that get generated out of the postmortem are treated like first-class tasks. I've been in places where some issues get created out of the postmortem in Jira or whatever it is, and they're relegated to some backlog that isn't taken very seriously. They need to be elevated as important issues so that we can actually learn from the mistakes and improve our systems. Practice. It's important to practice your incident response plan. I'm sure some of you in this room have to be SOC 2, Type 2 compliant, or PCI DSS compliant, or ISO 27001 compliant. And so there are some requirements on how often you should be doing things like tabletop exercises, usually at least annually. I think you should be doing them as often as you can. Some of these other things like simulation drills, red team exercises, and war games, you can do whenever you really feel like it. You can limit the scope of those and the people involved to a smaller group, but tabletop exercises generally involve a lot of folks and a lot of expensive folks, and those meetings can get expensive. But you should definitely do those as often as you can, and you should, certain events in your company's life cycle should trigger tabletop exercises. Considering the market in tech right now and the fact that there have been voluntary exits, involuntary exits, if there is a change in your staff, you should follow that up with a tabletop exercise to make sure that the people that are remaining in the organization know how to manage an incident, have access to the tools that they need to manage an incident. So this is actually a scenario that I've used in the past with tabletop exercises. Oh geez, I'm running out of time. So yeah, we had, let's say where there was a database tables had been dropped. Our systems let us know that. So I was the facilitator of the tabletop exercise. I wanted to make sure that the team knew what needed to happen as part of the incident response plan. Any guesses as to the first question that was asked when I let everybody know that we were going to be doing a tabletop exercise? Any guesses?
What is it about so I can be prepared?
That's close.
Why?
That's another question that did come up. What is the incident response plan? Was the question, which was frustrating because they were supposed to have read it. They said they'd read it. We were in a tool where everybody reviews policies every year, and they say, yep, I read this, and nobody could even find it. So that was a gap that was identified and let me know there was a cultural problem I needed to solve. It was important. So I'm going to try to run through this to make sure I'm on time here, but basically the scenario, as a facilitator, I'm asking questions. Do we know what the plan is? Do we know who the incident commander is? Do we know who the different people on the response team are? Do we know how to get access to the logs that we need, right? So one thing that we uncovered was that people didn't have access to the RDS logs. The people that we had actually just done a reduction in force, and so the people that were remaining didn't have permissions to get to the RDS log. So this was an important find. RDS is the relational database services in Amazon, in AWS. Can we limit the blast radius of this thing? Can we prevent any further database tables from being dropped? How do we identify whether or not this was internal or external? Once we bring things back, how do we validate the integrity of the data that we restored? And then how do we have a postmortem? When do we have a postmortem? All those questions were being asked. An actual incident. So this is kind of an amalgamation of some different DDoS attacks that I've been through. Basically, we had a DDoS attack. Certain parts of the application were down. Some things went well, some things didn't go well, right? So one of the first things that had gone well, we had a team. The response team came together, handled the incident in accordance with the plan. We identified the cause of the issue and were able to block IP ranges. We communicated with internal stakeholders and external stakeholders, and we hit our SLAs. What went wrong? The response team was too big for too long, which means there's an all-hands-on-deck approach to handling incidents. So all of the engineering team, all the security team was on a Zoom call, and they were all in it for like the entire duration of the incident, which wasn't necessary. People could have been doing other work. A few minutes in, we understand what's going on. We can say, hey, you all can go back to what you're doing, but that didn't happen. Again, key personnel didn't have access to or experience with the tools that we used for forensic evidence collection. The person that resolved the issue was also the person managing communication, so They're mitigating the issue, but they're also communicating with the CEO. They're also working with the marketing team to get an email out to our customers. Too much going on there. And if we had understood some of the tools that we had, that we were paying for, then we could have actually avoided this altogether, right? We were using Cloudflare. Cloudflare has some pretty good DDoS protection. We just weren't using it to its full abilities. Tools, so these are table stakes. If you're in the cloud, I know AWS's stack pretty well, so I'm just going to focus on that. You have to use GuardDuty if you're in AWS. No questions asked. You have to use CloudWatch and you have to use CloudTrail. GuardDuty is threat detection. You can set up some notifications so that you are notified either via email or Slack or through whatever notification channel you choose to know when things are happening. You need to use CloudWatch to manage metrics and dashboards and logs, and then CloudTrail to really record all the activity that's happening in your account. So CloudTrail works on a per account basis. You can set up different trails to handle to log different kinds of activity. And then in addition to that, you can set up VPC flow logs for your VPCs to really monitor network activity. Same for GCP. These aren't really like one-to-one comparisons, but those are the tools in GCP and Azure. Tools that are not native to these different CSPs that I've used in the past, Datadog is great. It's got a SIEM that can be pretty expensive, but it's useful. Sentry is great for error monitoring and tracing. Rootly automates a lot of the incident response process. So when you have an incident, you can spin up a Slack channel for you. You can spin up a Zoom call for you. It can, when you're going through the incident, everybody that's in the channel can actually tag messages in Slack that get added to a postmortem document that you can review in your postmortems. I think everybody here knows what PagerDuty is, maybe not, but I'm on call right now. Unfortunately, I forgot to take myself off. And you can schedule your on-call rotations. Cloudflare isn't traditionally thought of as a security tool, but like I said, it's got great protections. Lessons learned. Preparation is key. You really need to understand your cloud environment. You've got to be fast. You've got to save time, resources, and money. And you've got to be well coordinated when you're managing your containment and recovery. And you've got to continuously improve. You've got to have an attitude of continuous improvement as you are working through your incidents. And I think that's it.